Today we're going to take a look at graphing logarithmic functions. Since logarithms aren't the easiest to evaluate, we usually use exponentials to evaluate them. That's exactly how we're going to graph them as well. So we're going to start by creating a t-chart for 4 to the x, and then remember inverses switch the x and the y. So because inverses undo each other, they switch the x and the y value. So once we come up with our t-chart for 4 to the x, we're going to switch the x and the y values to create our t-chart for log base 4 of x. So starting with 4 to the x power, we're going to do a basic t-chart with our 5 normal values, -2 through 2, for to the -2 power. Remember, when you evaluate a negative exponent, what that means is that you flip it to the denominator. So it becomes 1 over 4 squared, or 1/16. 4 to the negative power, the -1 power, moves it to the denominator, and it becomes 1 over 4 to the first power, or 1/4. 4 to the 0 power is 1, 4 to the first power is 4, and 4 squared is 16. So because the log function is the inverse of the exponential, again, we're going to swap the x and the y values. So all those y values will become our x values for the log function. And all the x values will become our y values. Next, we're going to come up with the domain, range, y-intercept, and asymptote for the exponential function. This is a new parent function. The base is 4, but all of these values are the same as all exponential functions, no matter what the base. The domain for any exponential function is all real numbers. The range is y is greater than 0. Remember, taking a look at how we evaluated the exponential with negative exponents, the values are positive. They just kept getting smaller and smaller, closer to 0. The y-intercept occurs when x is 0. Anything to the 0 power is 1. And then the asymptote is that value that the graph approaches, which is 0. So y equals 0 is the asymptote for our exponential function. So now we're going to do the same thing with our log function. The domain, so notice because the x and the y switched, the range of the exponential will become the domain of the log function. We just need to switch that to an x. So x is greater than 0. You cannot put a negative value into a log because you cannot get a negative answer for an exponential function. The domain for the exponential will become the range for the log. So notice that for our log function, we do have negative y values. Because the x and the y switch, this time for the log functions, we will have an x-intercept, switching the x and the y, so our x-intercept becomes 1, 0. And again, switching the x and the y, the asymptote becomes x equals 0. So we're going to graph both of these functions on the same set of axes so we can see that reflection across the line y equals x with our two functions. So I'm going to graph 4 to the x first, and this is the one that we're kind of used to seeing. So we have our asymptote along the x-axis and plotting our points, and I'm going to count each of these as 2 since we can't fit 16 on the graph either way. So -2 up a 16th, -1 up a 4th, and then 0, 1, and 1, 4 would be the ones that fit on the graph for our exponential. All right, and swapping those x and y values to plot the log function. This time, the asymptote is our y-axis. So plotting our logarithm values, we have 1/16 -2, 1/4 -1, 1, 0, and 4, 1 that fit on our graph. So there's a rough graph of our log and our exponential functions. And again, that last thing that I want to do is remind you of the relationship, or at least the graphical relationship for inverse functions. You can flip them across the line y equals x. So if you imagine that line on the graph through the center of the graph with a slope of 1, and you can see visually that our exponential and our logarithm functions are reflected across that graph.